બરાબર
So good afternoon, everyone.
બરાબર
There are 30,
હમ હમ હમ
29 students are there from the
કાંઈ વાંધો
entire
નહીં. હાલો તો
class.
બીજો કોઈ ઓપ્શન હોય તો મને જણાવો
We'll
તમે.
wait for 2 minutes, okay? Then we'll start. Okay, so good afternoon. Am I audible? Yes or no? Please.
Yes, sir.
Okay. So what we have done in the last lecture, from that we need to start our discussion of this lecture. In the last lecture, we have discussed on the various stuff like types of code, the replications, why that types of code is required. We have discussed about the binary, decimal, their conversion, then the gray code, BCD, ASCII code, and such type of the things we have already discussed in the last lecture. So today we need to start with the quick revision of this particular stuff, gray code, and in the last lecture also that some of the student has given me the answer that how we can get the gray code like from the binary by doing similar such type of the XORing operation. So you just need to do the XORing with the next digit and you need to generate the answer in the gray code likewise. We have also seen a circuit like this also, like whenever you want to convert from binary to gray code, so such type of the XOR based circuit that we actually require. Okay, so that we have discussed already. Then after we have discussed about the BCD. We have also differentiate the BCD, then octal and hexadecimal conversion from the one number system to the another number system, and how to convert from this decimal number into the BCD number. That also we have discussed in the last lecture. We have also done the introduction about 8421. Okay, so that 8421, which is a BCD code, as well as there are a 2421 code is there. So if you can see this table 8421 and 2421, you can get the idea. Like whenever there is 8421, so we can say according to the weightage, your decimal number is going to be represented. Like you can say if you want to represent, let's take up to the number 4, then the system is going to be same. Like in 2421 and 8421, both number will look like same. But when you go to the 8421 with the number 5, so you can say how this number 5 will represent. That weightage of 4 will be 1, weightage of 1 will be 1, so you can get 0101 answer. While similarly, or we can say the similar decimal number like a 5. Let me first take some of the laser pointer. Yes. So if you can see that the simple number 5, if you just take the equivalent to 2421, you can see that number is different, 1011. So how this 1011 will came? It's going to become like, first we need to give the priority to the highest number. Okay, so over here this highest digit is 2, so first it will give the number 1 to that highest number, then rest of the thing is going to be calculated by the rest of the numbers. So that's why it's a 2 weightage with the 1, again 2 will be weightage with the 1, so 2 plus 2 4, and then 1 weightage with the 1, so it's going to be 1011. So likewise, this 8421 and 2421 will be differ after the number 5. And according to that highest side of the digit, you need to give the first priority to them. Similar, I can say in a similar manner, whenever you are representing the other digit also, like if you are representing the 9, so in 8421 will be like 1001. But in 2421, you need to use all the digit like 2421 and so on. So likewise, you can represent the number 9 and 7, 6 and 8 and all this stuff. Okay. So these are the some of the stuff we have related to the 8421, 2421 and all stuff. We have also discussed the stuff related to the XS3. Right, XS3 is nothing but like whatever the decimal number is there. First, we need to convert into the binary. And then after you need to add the binary number into the 3. So we can say once you will add this number into the 3, so that's answer will be going to be excess by the 3 digit. So that's why 0 in a decimal can be represented in XS3 as a 0011. Why? Because plus 3 is going to be added on their binary digit. So if we can say, if I'm having an XS3 representation of the decimal number 359, so what is the equivalent answer? Like what is in place of the 3, I need to place 0110. Like this one. Instead of 5, I need to write 100, and instead of 9, I need to write 1100. So this XS3, BCD and all stuff already we have discussed. We have already just done some of the discussion related to the ASCII character. Like I have given the example. मैंने last lecture में example दिया था कि जब भी मैं कोई key या कोई भी button press करता हूँ, so how your computer will know that like this is the actual number, it is behind that actual number has been pressed actually. So there is one ASCII character, is ASCII chart is there, and from that ASCII chart, that different hex code is going to be generated, and from that hex code your system get notified like this number is going to be displayed. So there are in a ASCII chart, there are ASCII code chart is there, which is varying from 0 to 7 this side and 0 to F this side. So we can say there are a 16 cross 8 box of the table we have, which is representing your entire ASCII code chart. There are lots of kind of the buttons are there, like it's kind of the alpha that's alphabetic like A, B, C, D and all stuff, as well as there are having some 1, 2, 3, 4 numbers. There are some symbols and so this is just a sample chart, you can say, where you are having a small character, capital character, all this stuff we have. There are some information like delete and null. Okay, there are several buttons are there, and according to that they all have their particular functionality. Okay, Neha Nanwani, 2421. Let me first complete this ASCII code, then I'm going to again explain the 8421 and 2421. Okay, so in the ASCII code chart, how it's going to be decided? Like this is kind of the key, we can say keypad you can consider. Keypad, it means you can say these are the rows are there, like there are 8 rows are there. Likewise, there are 16 columns are there. So 8 by 16, this matrix, whenever you press that particular digit, so according to that, a number is going to be generated as a hex code. What is the example? We will see this example of this one. I'm going to see that what is a number for the K. Awadh Kumar, which PDF are you talking about? Hello, Awadh. This PPT, okay. Okay, this PPT lecture note. Okay, I'm going to upload this PPT in the Canvas. Don't worry. Sure, okay.
Hello.
So we will see like this is a K. So whenever we have the K, so what are the approximate or what are the possible hex code for that? So we need to see what is a row it will represent. It will represent the row number 4. And it will represent the 4. It means that digit is going to be 100. And what is the kind of the column is representing? Column is representing the B. So that's why it's going to be B1011. So likewise, that hex code is going to be 4B. Okay. So whenever you are pressing the K from your keyboard in your computer, it will send you that right now 4B number of the hex code generated from this keyboard, which is representing the number K, and then it's going to be decoded by your processor and it will give you the task accordingly. Okay. Likewise, you can say if you are having a S, there is an example, S is going to be represent the number 5. While we can say what is a column for that column. So for the 5, you can say this is a 101 binary representation of that, and that's another representation of the column, which is a 3. So it's 0011. So our answer is going to be 53 in a hex for this number S. So likewise, this ASCII character is going to be transformed into the hexadecimal code, and your system going to be identified from that. Okay. Now, if you can go that back a little bit as per the question from Neha, like what is 8421 and 2421? So you can say like 8421. So in 8421, you need to go with the weightage wise. See that if you want to represent the number 0, so you need to put the all the weightage to 00, then you can get the decimal 0 equivalent. If you want to get the 1, अगर आपको यहाँ पे एक चाहिए तो आपको ये 8421 सबका वेट है, मतलब कि ये डिजिट का वेट 8 है, इसका 4 है, इसका 2 है, इसका 1 है. लाइकवाइज यहाँ पे जो 4 डिजिट है उसमें फर्स्ट का वेटेज 2 है, सेकंड का 4 है, अनदर 2 है, बाद में 1 है. अगर आपको डेसिमल 1 चाहिए तो आप कहाँ पे 1 रखोगे? Obviously in the first digit, because that one weightage multiply with the 1, it will give you the answer 1 in both of the cases. That's the okay. नेक्स्ट यू कैन से यू गो विद द 2. तो आपको लेफ्ट हैंड साइड से सोचना है कि लाइक आप लेफ्ट हैंड साइड से मैक्सिमम कौन से बीट को यूज करके इसको रिप्रेजेंट कर सकते हो. फॉर दैट, लाइक इफ यू वांट टू रिप्रेजेंट द 2, so simply you need to take from the right hand side. If you are taking a second digit of weightage 2 in both of them, 8421 and 2421, so you will get the answer 0010 0010. If you want to get the 3, तो सिमिलरली आप 2 का एक वेटेज लोगे तो वहां पे 1 रखोगे, 1 का वेटेज पे भी 1 रखोगे तो 2 + 1 3 हो जाएगा. इट इज ओके. 4 चाहिए तो आप ये सब डिजिट फिल हो गए, लाइक अभी यहाँ पे कुछ चेंज नहीं कर सकते. सो यू नीड टू चेंज द नेक्स्ट बीट, लाइक इट्स गिविंग एज अ 1 ओवर हियर, 0 0 over here, and then 1 0 0 over here. So that's 4 is also going to be represented this one. Now it's come the part of tricky position. Let's take the 5. अगर आपको 5 रिप्रेजेंट करना है, सो 8421 में तो आपको पता चल जाएगा भाई 4 का वेटेज ले लो 1 और 1 का वेटेज ले लो, तो दोनों को एडिशन करके आपको 5 मिल जाएंगे. लेकिन what we can do in BCD, you need to give the first priority to the number which is available in the last. Like ऐसा है कि यहाँ पे अगर 5 नंबर रिप्रेजेंट आपको करना है, so for that you first need to give the priority to the highest number over here. So you can say that highest number is over here. This is weightage having the 2. So that's why from the 5 onwards, you need to first give the priority to the 2 first. Then you need to come to the rest of the digit. So 2 यहाँ पे हो गए तो बाकी कितने बचे? 3. So 3 करने के लिए आपको क्या करना पड़ेगा? 2 के साथ 1 और 1 के साथ 1. अभी लोगों को क्वेश्चन आता है कि भाई मैं 4, ये मुझे 5 रिप्रेजेंट करना है, ठीक है. अगर मुझे 5 रिप्रेजेंट करना है तो मैं यहाँ पे 1 लेने की जगह पे यहाँ पे 0 0 1 0 1 क्यों नहीं लिख सकता? दिस इज द मेन क्वेश्चन वी हैव. तो भी 5 हो जाएगा 2421 में. बट in the 2421, what that actually are going to be aim, okay, that actually it is going to be aim like whenever you are converting the number, you need to think for the higher digit. Like अगर हायर डिजिट से वो रिप्रेजेंट होता है, देन यू नीड टू गो विद द लोअर डिजिट. आप हर जगह पे ऐसा सोचिए कि अगर मुझे कोई भी नंबर यहाँ पे रिप्रेजेंट करना है, अगर मुझे 7 रिप्रेजेंट करना है, सो फर्स्ट आई विल गिव द प्रायोरिटी टू द हाईएस्ट डिजिट. ठीक है कि भाई लास्ट डिजिट से वो हो रहा है, नहीं हो रहा है, देन यू डिक्रीमेंट बाय 1. इससे हो जाएगा 8 9, देन यू डिक्रीमेंट बाय 1. इससे हो जाएगा नहीं, देन यू डिक्रीमेंट बाय 1. सो लाइकवाइज यू नीड टू गिव द प्रायोरिटी फ्रॉम हाईएस्ट नंबर टू लोएस्ट एंड यू विल गेट द आंसर लाइक दिस वन. सो दिस इज अ फिलोसॉफी बिहाइंड दिस 2421 कोड. इसलिए मैंने यहाँ पे इंस्टेड ऑफ 0101 की जगह पे 1011 लिखा. समझ में आ रहा है या नहीं नेहा? यस और नो? इट्स डिपेंड अपॉन द प्रायोरिटी. आपको लास्ट डिजिट से सोचना है. मैं यहाँ पे आपको ऐसा बोलूं कि 2 नंबर आपको रिप्रेजेंट करना है. ओके, सो इन दी टू व्हाट यू कैन गो फ्रॉम द नेक्स्ट डिजिट, फर्स्ट डिजिट लाइक 8421. सो यहाँ पे 2 कंपलसरी आपको यहाँ पे लिखना पड़ेगा. ओके, बट व्हेन यू आर राइटिंग दिस 2 ओवर हियर, यस, इन 2421 वी हैव टू प्रेजेंट बाय 4 by 1010. Okay, so that's the, as per the priority, yeah, 101. बट आप यहाँ पे लास्ट से आप प्रेजेंट कर रहे हो ना, लाइक यहाँ पे 2 नंबर आपको डायरेक्टली मिलते जा रहा है. Let me go with that one. I agree with your point. Why there is a 242110. Let me go with that 2421 code converter code table. Let me go to this internet and we will go to stuff like this one. See that. That's the another stuff regarding the complement. Okay. Self-complementary code, we can say. We will go with this stuff and we will see how their 2421 is going to be represented. Let me just share this stuff with your see this video. So this is a reason आप यहाँ से पता कर सकते हो कि भाई आप 4 के लिए जैसे आपने बोला 1010 को रिप्रेजेंट कर सकते हो. So which one is going to be correct? That is going to be identified by the self complementary. So this thing, this table, okay. Hello, Sumant, for this particular, one thing that I have forgot to add, there are a 9's complement that we need to first consider before going to that particular code conversion. That's why this priority and all stuff, it's not going to be compared initially. So you need to start with the middle one, like it's starting from the 0. Like where's the table? Yes, starting from the 0. So 4, 5, 6, 3, 2, 7, 1, 8, 9, 0. Likewise, there is a complementary stuff we have. Now, according to the complementary, whatever the correct one is there, correct one, that we need to use. Okay. So let's see how this table is going to be happen. So this is a 0, and what is the complement of that? 1, 1, 1, 1. So that is going to be a 9. So that's why in 9 you need to write 1, 1, 1 all the place. That's why it's going to be down to the 9, 1. One, 1, 1, 0, 1. So this is the reason, like out of this 2, 1, you have asked, like as per the priority also, we can choose 1, 0, 1, 0, but we need to set that whether it is a self complementary with the above or not. If it is satisfied, then we can go with that. Otherwise, we need to just take care that whatever the number is available from this one, that should be in a complementary with the respective of that number. So instead of if you are giving a highest priority to 4 by representing the 1010, so it is not going to be matched with the downwards. That's why it's going to be considered as a 011 instead of 1010. Okay, it's also going to be happen at the 2. Like why we cannot go with the 1000 because 2 is highest priority? Because whatever the 2 we have, that's complementary, it must be satisfied with the 7. That's why this 1101 is represented over here as a 010. Is it okay, Sumant and Neha? Through this video link also you can revise as well as this is the stuff. Yeah. So if we represent 2 by 100, then it's complementary of it's made 7. Yes, if you go with that, but at that time 7, we can say yes. If you are taking 1 1, yeah. So at that time 7, you can say it's going to be down like the I can say that's a 0. Instead of this 1 1 1 0, instead of you can write 0 1 1 1. Yeah, true. So whatever the number you are representing, just complementary of that you need to use. So if that both number is not going to be matched, then it's going to be wrong. But if both going to be matched, like if 2 is you are representing over here as a 1000, then it should be 0111 like that. Like if that complementary from this both of the side is going to be satisfied, then table is going to be correct, you can say. I'm saying that Sumant, if you are using a 011 over here and you are taking a 7, so that both is going to be correct, but you should take care the complementary should be reflected in the down. Okay, so that's the stuff is going to be it's going to be represent. Another thing you can say, like if you will judge like which one is going to be correct, I need a correct answer for that. I will say from the standard practice, you start with the similar as a 8421, like up to the 7 number, you can say not for the 7, up to the initial 4 digit, you follow the same rule as a 8421, and then after decide the rest of the number by their complement. So that's going to be a correct procedure we can follow. But if you want to go with that non-comparative analysis, like 8421 जैसे था, मुझे ऐसे नहीं लेना है, I am going to take as a complementary, मैं वहां पे satisfy कर दूंगा, then you can take that table also, it's not an issue. But यहाँ पे कंपेयर करने के लिए कोई 8421 में 0 से 4 तक सेम ही कोड थे, लेकिन 8421 में उसके बाद कॉम्प्लीमेंट्री कोड नहीं है, उसकी जगह पे 2421 में उसके नीचे कॉम्प्लीमेंट्री कोड है. दिस इज अ डिफरेंस यू कैन से. सो इफ यू आर मेंटेनिंग लाइक दैट, then it is going to be correct, I can say, in a more practical in manner. So that's going to be understood by easy. Otherwise आपको सब टाइम आपको ही बोलना पड़ेगा कि भाई मैंने इस तरह का कॉम्प्लीमेंट नीचे यूज किया है, so you consider like that one. If you simply say like that, first initial digit, which is a normal number, which is same as a 8421, and then after it is a self complementary, so you can distinguish that rest of the number are weighted with the 2421. आप ऐसा बोल सकते हो कि भाई पहले 4 डिजिट थे वो मेरे पास जो आए हैं वो 8421 की जैसे ही थे, उसके बाद के सब कॉम्प्लीमेंट्री है, तो आप कह सकते हो कि वो 2421 BCD है. Is that okay, Sumant? Neha? Okay. Sumant Kumar? Hello? Yeah. क्योंकि गलत नहीं कह सकते हो ना, आपने सिर्फ कॉम्प्लीमेंट्री सेटिस्फाई करने को बोला है, सो यू कैन सेटिस्फाई विद कॉम्प्लीमेंट्री. बट इफ यू वांट टू डू द जनरल रिप्रेजेंटेशन, तो अगर आप 8421 के साथ कंपेयर करते हो तो आप ऐसा कहोगे कि फर्स्ट 4 तक दोनों का सेम रहेगा, बाद में अगर वो 8421 वेटेज के हिसाब से रिप्रेजेंट कर रहे हैं तो वो नंबर रिप्रेजेंट करेगा लाइक 8421 अकॉर्डिंग एज यू आर डूइंग इन बाइनरी. बट if you represent the self complementary, then उसके बाद उसके complementary करने के लिए आपको पहले है वो 8421 के जैसे ही first 4 digit आपको represent करने के. Both is going to be correct, you can say. Now if you'll just move to the stuff like where we have, yeah, so we have done with the ASCII, we have done with this code. ASCII code chart is there, we have can find out for the S also. Now conversion from any number into a system. So this already you know, like if you are having this number, there is a I can say that a fraction number also. So how you can represent in the fraction, you can say like that after the point that power is going to be started from 2 raised to -1, -2, -3 and so on. So before the point there are a positive power is there, then there are a negative power is there. Okay, so likewise if you just convert this number with their weightage like 1 into 2 raised to 3, then I can say I'm going to say 0 into 2 raised to 2, 1 into 2 raised to 1. So according to that, you can represent this stuff. like in from fraction number to the any particular decimal also. So this is the answer, like it's going to be 10.25 for this fractional binary to the decimal, fractional decimal you can say. Similarly, if there is a octal, so you just need to change the weight instead of the 2 that you have used it previously because it's a binary. But यहाँ पे हमारा octal number है, so you just need to simply say 2 into 8 raised to minus 1, 8 raised to minus 2, 8 raised to 0, 1, 2, and you just need to multiply by their weightage 3, 6, 5, 2, 4, and the calculation of all of them that you need to write as a decimal number. So that's a simple fractional number to the decimal representation we have. If you can go with the hexadecimal, then also you can say 4C8. Now you need to use a weight of 16. So 16 raised to 0 multiply with the 8, 16 raised to 1 with the C, 16 raised to 2 with the 4, and 16 raised to minus 1 with the 2. So overall answer will be represent like this one. Now decimal to binary conversion, this is also the one of the stuff that you already know, like decimal to binary or decimal to octal, decimal to hexadecimal. How you are converting? You are just doing a successive division method. And in the successive division method, whatever the remainder are there, that you are going to note it down. And from then you need to start from down to upward. You need to go with that most significant bit and less significant bit. So you need to go from down to upward. If that number is going to be we can say its number is going to be non-fractional, then you need to go from down to 1 in the successive division method. So if you are having the 6, so their binary representation will be like 2 divided by 3, remainder is going to be 0. Then 6 divided by 2, answer is 3, remainder 0. Then whatever the kind of the part we have, okay, 3, again you need to divide with the 2, whatever the remainder you need to write. And at the last digit you need to reach to the 0 point, like 1 cannot be divided by 2. So we can say that's a 0, that's why that last digit is going to be 1 came, and you need to start with the 1, 1, 0. So this stuff already you know in your digital fundamental very well. So decimal to any number system, if I'm having the successive division, so you need to go from down to upward. But if I have a fraction number, so fraction number going to be treated separately, like fraction number will be separated like it start with the successive multiplication. So what you need to take this 0.42 pass with the multiply by 2, and whatever the first digit is there before this dot or before this point, so that you need to consider as your answer. So 0, then you need to do 0.84 with the 2, then 1.68. So now you take a 1 out of that, and remaining 0.68 again multiply with the 2. You need to again take this 1, remaining are 0.36. 0.36 multiplied by 2, 0.72. So 0 you need to take, again you need to go with 0.72. So answer is 1 point, so you need to take 1, and likewise you need to go from up to downward in this type of the system. So what is up to downward? 0, 1, 1, 0, 1. So that 0 point something, the binary representation is there. So once you add both of them, so once you just combine both of them, so answer will be 1, 1, 0, 1, 0, 0, 1 point 0, 1, 1, 0, 1 like that. So this is the overall answer of your particular decimal to binary conversion you have. Is it okay with everyone? Any doubt, any question in this one? Yes or no? Okay. So now everybody need to do this calculation, like already you know that. Just a second. Whatever the number is mentioned over here, 105.42. Now it's your task that convert this number 105.42, which is decimal, convert it to the octal and write the answer in the chat box. Everyone, do this calculation. I will give you a 5 minutes to do that. Okay, do this process and just give me the answer. And so we are going to cross verify with your answer that please do the calculation of 105.42 in decimal. Convert it with the octal, same process you need to follow, like non-fraction number division, fraction number multiplication, that same process. So in previous we have done with the multiply by 2 and divided by 2. Here you need to do with the multiply by 8 and divided by 8. Simple stuff is there. Okay. So everybody do this particular stuff, and in 5 minutes you need to write the answer in the chat box that what is the conversion of this digit decimal into the octal. Everyone start doing that. So please write your answer in the chat box of this particular number 105.42. Yeah, so many student has written the answer 151, 3270, 24 and so on. Okay, so some of the answer 151, 4270, 327, 3270. Okay, we will check. Answer will be 151, 32702. So that would be a right answer for everyone. So you can do like it's a 105 divided by 8. It's 13 will be there, remainder will be 1. Then 13 divided by 8, so remainder will be 5. And then there is a reminder that 1 cannot be divided by 8. So answer is 151. And then in fractional, it will come with a 32702 like that. So that answer is going to be correct. Yeah, so most of the students have got that. Good one. Next, what we have, like the complement. Okay, so several times this complement is going to be a very confusing in every time when we are calculating this stuff, whenever we are doing the arithmetic operation and all stuff. Can anybody tell me why complement we required? Just open their mic and can you tell me the stuff like why actually the complement we required? Yes, open their mic and tell me why we need a complement. To represent the negative number, true. So to represent the negative number, we require the complements, and like we can say, like whenever we are doing arithmetic calculation at that time, directly that subtraction is not going to be possible. There are a summation is going to be there, as well as you can say the subtract instruction also there, which is ultimately addition, but with the one that one of the number is get complemented first and then it's going to be entered. So such type of the stuff is going to be happen whenever you are using a we can say whenever you are using kind of the complement and the addition of the two number. So we will see like what are the complement and what are the representations. So radix complement is referred to as R's complement. Okay, diminished radix complement which is just referred as a R minus 1 complement. You can say like radix complement, we can say if your decimal number, so radix complement will be 10s, and what is a diminished radix complement? 9s. So we can say 10x is a radix complement, and just one number small from that, which is a diminished radix complement is there. So 9s and 10s will be represented like this one. If you are having a binary, so it's a 2s and 1s complement. So what is 2s and what is 1s complement, that we need to see over here. So simple, complement is nothing but the just opposite number of that one in binary. So if 1, then 0, 0, then 1. So if number is 1, 0, 1, 0, 1, answer is 0, 1, 0, 1, 0. So that's the 1s complement. What is a 2s complement? Whatever the answer we have got in a 1s complement, you just need to add the 1. So that's going to be like 1, 0, 1, 0, 1. 1s complement will be 0, 1, 0, 1, 0. Just add by 1, answer will be 0, 1, 0, 1, 1, simply. So that's the basic difference between 1s and 2s complement. If we can go with the 9s complement and 10s complement of the system, so how 9s complement represent? 9s complement will represent like you need to just take it complement from the 99. So 99 it will complement will be 1 and 9 minus 2 it's going to be 7. Or simply you can say whatever the maximum number in that with that complement, which is a 99, if there is a 2 digit, so that's 99. If there is a 3 digit, then it's a 999 likewise. So 99 minus 28 complement is going to be 71. Or you can simply say this number how much far away from 9. That also we can say the complement of that number. Or this number is how much far away from 9, so we can say that's 7 and this is a 1. Simple, in a 10s complement, whatever the 9s complement answer we have, you just need to do the plus 1. So that's a 10s complement, simple. Now there are a representation is there in a binary. So according to this representation, we can identify like what is a magnitude representation or 1s complement representation, or we can say there are a 2s complement representation. So we will see. So first, which is a sign magnitude representation, like if this is a 0 out of this 8 digit, if your first digit 0, then there is a positive number. If there is a 1, then it's a negative number. So I'm talking about the sign number, like you have seen in the data type in computer programming, sign integer, unsigned integer. So unsigned integer, this is a complete 8 digit are there. But if there is a sign integer, then first digit represent as a sign, positive or negative, and then rest of the number will be represented as a value. Okay, that's why you can say unsigned integer having a value of 0 to 255, while signed integer having a value of minus 128 to 127. Okay, that is the reason why, because first digit is going to be reserved for the assigning the sign of that particular number. So if there is a 0, then there is a positive number. If there is a 1, then there is a negative number. So now I am having a 12 sign digit is there. So if I am having a 12, so normal representation of 12 is going to be 0, 0, 0, 0 and 1, 1, 0, 0. So that is an 8-bit representation. So I can say first digit is going to be 0. Rest of the digit is going to be like this one. Okay. And sign 1s complement of that one will be like this one. The same number, whatever they represent in the sign magnitude, which is a complement, is also going to be same for that. Okay. Can you tell me why? Why the 1s complement of this plus 12 will be the same? Hello. Anybody tell me why there is a sign magnitudes that 1s complement will be represented as the same? There are no 0 and 1 conversion is there. The same stuff I have represented. The reason is there, like for the positive number, we have not defined the complement. As you have told, like why we required a complement. You told me that it's to represent the negative number. So this positive number doesn't require the complement. Simple answer is there. So we can say whatever the 2s complement, which is also the same as the same number represent as a sign magnitude. But if you go with the minus 12, then first number represent as a first digit as a 1, rest of the number as a 12. But 1's complement of that one, that first digit going to be as it is. See, first digit going to be as it is, rest of the number will pass through the complement process, like 0 become 1, this 0 become 1, this 0 become 1, 1 will be 0, 1 will be 0, 0, 1, 0, 1, like that. As well as the 2's complement, you need to add 1 in the last digit. So if you add the 1 in the last digit, so 1 plus 1, 0, 1 carry will be there, then 1 plus 1, 0, then 1 carry will be there, then 1, 0, answer is going to be 1, then 0, 1, 1, 1, as it is. So whenever you are having a negative number, then and then only the complement is need to be applied. Next, we have having a floating point representation also. So in floating point representation also, there are a separate kind of the identification are there, like floating point representation. First will be given as a sign magnitude. Okay, then it will give as a sign magnitude of the exponent, then exponent, and then there is a rest of the stuff we have. So that's example we can say, which is like this one. So 11.8, which will be represented as a 1011 point, this type of the number is there. So we can say what you will do, like that's a multiplication of 2 raised to 3, you can say. So whatever the number you have, if you multiply with the 2 raised to 3, simply. Okay, so if you have multiply it with the 2 raised to 3, so this dot is going to be shifted over here, 1011, like that. So then only it's going to be represented as, initially there is a digit is there, 1.0111, then there is a multiplication, and then there is a rest of the digit are there, 0, 1, 1. So if you can go with that block, so you can say this is a 0, 0, 0, 1, 1, 0, okay, 1, 1, 1, 1. This is a number is going to be represented over here. How it will be there? Just a second. So I can say initially that number is going to be positive. Okay, number is going to be positive, and then let me go with that example. 1, 1 is 1, 0, 1, sorry, 1, 1, 0, 1, 1. Okay. So exponent, like first it will start with the sign, then sign magnitude of the exponent, and then there is an exponent. Then there is the rest of the number. So how it's represented, like we will see over here, like it's going to be like, yes, it's going to be like, it's a positive number, that's why it's a 0. Then there are a number is there, that number is going to be 1. Okay, so that's why it's going to be like 0, 0, 1. Okay, and then it's going to be rest of the number just after that, rest of the number just after that, that 0, 1, 1 will be 0, 1, 1. I think that number is just shifted to the little bit of this one. Sorry for that correction, but let me go with the example number 2. There I have some typing mistake I have done. 0, 1, 1, 0, 1. So 2 raised to. So just leave for this example number 1 and 2. There are some of the mistakes that I have made to writing in that number. So I will come back on this example 1 and 2. Don't worry about that. Let me just correct this one, like it's a 2 raised to power 0, 1, 1, and how they have represented stuff with this, the wrong one, 0, 1, 0, 0, 1, 1. So that I think interpretation is going to be something different. But don't worry about that. We'll come back on this particular example 1 and example 2. But up to this particular point, what we have learned in this entire lecture, like if we can go with the last example, so we have studied about the complement, numbers, 8421, 2421, complements, and their conversion from one number to another number system. Okay, so this is a stuff from my side. If you have any doubt, any query, rather than this example, last 2 example 1 and 2. Okay, apart from that, if you have any query, any doubt, so you can ask me. I'm open for the question now. If you're not having any question, any doubt, so I request, please just write your summary of this entire lecture, that what you have studied in detailed summary, and then you write your enrollment number and name, and then you can kind of leave and wait for the next lecture if you have. If you have any doubt, any query, please ask me. Otherwise, please write the detailed summary of the lecture. So don't copy and paste मिहिर शुक्ला डॉट सब कुछ ऊपर से कॉपी करके नीचे लिख लिया. अपने वर्ड में भी कुछ लिखो. माहिर शुक्ला, हेलो माहिर, प्लीज सेम टू सेम. चलिए, अपना नंबर सिर्फ लिखना रह गया माहिर, बाकी सब कॉपी हो गया. डॉट से लेके सब चीज देखिए. डोंट डू दैट मैन, राइट इन योर वर्ड. So after writing your yeah, sorry for the interruption. So after writing your enrollment number and name, you can leave and wait for the next lecture. Thank you, everyone.
Hello, sir? Hello? Sir? Hello, sir? Hello?